All right, so when we're asking you to think about ionic compounds, here is what we want you to be thinking about. So let's start with the ion makeup. We want you to look at the formula and recognize what ions are present and how many. So we start with the fact that there's a K in there. I only read it once because there's no subscript. It's not K2. But again, it's an ion. So it's an ionic compound, which means it is not just K. You need to look at your periodic table and recognize that, okay, K has, when it forms an ion, it's going to be a +1 charge. So if you're looking at your periodic table and you're not sure what that means, or that's not on your periodic table, I'm going to draw one right up here to help remind you what we need. All right, so on the very first group, they all have one valence electron, so the charge they're all going to form is a +1. Second group, they have two valence electrons, so they're going to form a +2. We're not going to worry about the D block. We're going to jump over, and in the group number 13, the only one really worry about is aluminum, so that's going to be a 3+. Then the carbon column, we're not going to worry about that. It does not form ions because gaining or losing 4 electrons is not something that naturally we see happening. So then we go to the nitrogen. That is going to be a 3-. Oxygen is a 2-, and the fluorine column group is a 1-. And then the noble gases, we don't assign them a charge because, again, they're not going to form ionic compounds. So that's how I know that K is a +1. And then it would follow that bromine is going to be a -1. So that is the ion makeup. We want you identifying how many you have. Sorry, that and that. Okay, so then transfer of electrons. All right, so then what we want you to do is you stay with writing those same amounts of them, but now you need to show the Lewis dot structures. Because what happens in a compound is the ions are formed and then they can attract to each other. So based on where potassium is on the periodic table, it has 1 valence electron. Bromine is in the group that has 7 valence electrons. So what you're showing for the transfer is you need to show an arrow from the metal to the non-metal. It does need to be an arrow. An arrow is something that actually has a directional component to it. So you're showing the electron is going from the potassium to that empty space in the bromine. Okay, then the crystalline structure. So now the things we want you to show for the crystalline structure, we want you to recognize the ratio that those ions are in, as well as the arrangement showing that opposite charges attract. Half of chemistry is opposite charges attract. The other half is everything wants to be stable. So I'm going to start with the ratio. So I need a potassium ion attracted to a bromine ion. So we want you to draw, you're just going to use a circle to represent the ion and put the symbol in the charge in there. So then I need to draw that's just drawing one of them, and we want you to draw 3. So then the second one I'm going to draw it right below. You have some options. I'm going to just start stacking them. But then I can't put the K+ next to the other K+. Those are not going to attract. They're going to repel. So I have the Br-, and then the K+. And then again, to draw a third one, K+, Br-. All right, so when I say we're looking for the ratio, for every 1 calcium, you have 1 bromide. You would not want to draw this because now you have 2 potassiums for every 1 bromide, and then that doesn't match the formula. All right, so that's the crystalline structure. All right, let's try the next example. Now we have a different ratio. We have 1 calcium for every 2 chlorides, or 1 calcium and 2 chlorides. So I start by writing how many I have. And then again, it's an ion. Ions are charged atoms. So based on where calcium is on the periodic table, take a look at that, see if you can figure out what the charge is going to be. Hopefully you recognized it is a 2+. Again, we'd accept it if you write +2, that we kind of use those interchangeably. And then the chloride, each of the chlorides is a -1. Transfer of electrons. I have 1 calcium, 2 chlorides. All right. Valence electrons. Calcium has 2 valence electrons. That's why it's going to form a 2 plus, because it will lose both of those to become stable. Again, half of chemistry is things want to become stable. Then I have my chlorides. Each one of them has 7 valence electrons. So then I'm going to show, again, to show the transfer, I need an arrow. Calcium goes into the open spot on chlorine to give that 8 valence electrons, which we find is the most stable configuration, or we're assuming is the most stable, because those are the ones that, happen in nature. All right, so that is your transfer of electrons. All right, then the crystalline structure. Again, we want you to draw 3. So this one, now my ratio is I have a calcium 2 plus, and I have 2 chlorine ions, or chloride ions, excuse me. So each one, you have to think about how they're going to arrange. So I can't put the chloride ion next to the other chloride because they're the same charge, so they're going to repel. So what happens is it goes on the other side. All right, then that's drawing one of them. Now I need to draw a second one. I have to think about, I can't just do what I did in the previous example and draw it directly under it because the ratio is different. So I just tend to move mine off to the right side. I have the calcium ion in the center, chloride ions on either side. My third one, I can go back to the same arrangement, or I could just scoot it over to the right again. You have a little bit of freedom in how you do this. Because again, these are going to form crystalline structures with many ions coming together. So which ions you choose to draw is up to you. But again, what we're looking for is you need to have the correct ratio and you need to have opposites attracting. And that is what we want you to do for that learning target.